Hi, I'm Bernat Esquirol. Thanks for tuning in. I will present Twitter users during the 2020 Spanish lockdown. This is my master thesis, and my supervisors were Emanuele Cozzo, Luce Prignano, and Professor Albert Diaz-Guilera. And we'll be characterizing the change in users' activity and interactions. Thanks for inviting me to Political Communications Network 2020. And the goals of this thesis are, first one, to measure the change in users' activity during the COVID-19 crisis, and we will do that by performing individual behavior modeling. And also we want to evaluate the interaction through the pandemic, so how different users interact during the pandemic. We will do this using the framework Ego Significant Alter Networks that we'll explain later. And while doing all of this, we also will take into account the difference between user types. We will have three user types. First one will be politicians. These are congressmen from Spain. We have journalists, and finally we have a control group that is the random users. How to get random users from Twitter is not an easy task, and what we do is getting a random tweet from the latest tweets, and we get a random follower or friend of the author of the tweet, and then basically we have two sets of followers, of random users. One is random followers and the other random friends, and one is biased towards having a lot of friends and the other one is biased towards having a lot of followers. Okay, we present here the first model we did to measure the activity, so the tweets per day, of an individual during the crisis. And then we will see global results with all the models. So this model is called stepwise segmented regression model, and basically what we do is finding the optimal number of breakpoints using the Bayesian information criterion, and also find where the breakpoints should be set so that the mean between breakpoints is a good model of the signal. So here we have an example. We have this signal, and what we do is just computing the Bayesian information criterion for each number of breakpoints. So here we see that the lowest is at 3, and then we just find where this breakpoint should be set in order to get the maximum amount of information with the least amount of data. So once we have a user, so an individual model, then we jump into global results to see if there is some tendency among all the users in our set. We create what we call jump values, that basically what we do is for each breakpoint we see if the signal increased a lot or decreased a lot in that breakpoint, and we normalize with the mean of the whole signal. If we do this for all our users, we can see this global plot, that basically what we see here is that the average user changed its behavior during the lockdown in Spain. Remember, this is not a frequency plot, but this is a change of behavior plot. The green lines indicate a positive change and to a higher level of tweeting, and the red lines to a negative change to a lower level of tweeting. Here we see the same result with different user types, and we see already that politicians behave a bit different than the other types of user. We have a model that simplifies the signal, and we wanted to create a second model with the same purpose to see if we can get a less noisy understanding of our data. So that's why we did the Bayesian switchpoint model, and basically we assume here that there is only one change in behavior in the whole timeline for each user, and that tweets happen randomly through time. When we model the signal using a Poisson model, and basically we change the parameter in the breakpoint. Here we have an example of an artificial dataset, and we see that it performs well because we see where is the change, and there's because it's Bayesian, it's all based on probabilities, so there's that. And here we see another example. Of course, here there are two changes, but we only pick one of them. And finally, we can perform the same type of analysis, and so just knowing if the change, the important change, so the breakpoint jumps to a higher or a lower value, and we get a similar plot with less noise. And here we have the same result for the politicians that are behaving differently than other users. Okay, finally we have the part in which we model the interaction between users in Twitter, and we we do this by using the framework Ego Significant Alter Network, and we will explain a bit how we calculate this. We basically pick a user from Twitter, that's the ego, and then in order to create the Ego Significant Alter Network, we compute the empiric distribution of the number of retweets that other users receive from this user. So we find the outliers of this distribution, and so the more retweeted accounts are in the higher positions, and then we just take the outliers of this distribution, taking into account the skewness. And basically these outliers will be the nodes of the ego network, the Ego Significant Alter Network, and then we will perform the same computation for each of these users, and if the outliers of the other are in the network, we will create an edge between them. And also, if we have a reciprocal edge, we will also create them. So for example, here we have a deputy from Spanish Congress, that's Irene Montero, and we see that they have a reciprocal relationship with Pablo Iglesias, that is the leader of the party, and we have also the party account, etc. And for example, here we have a far right deputy from Spanish Congress, and we can see that this is a bigger network and a more dense network. Okay, so just with that we can perform some global analysis of the structure of the network, and we can see also that politicians tend to have more degree in the network, and also a higher clustering within the network. And so this is one step, and then basically what we do is we want to see the evolution of these Ego Significant Alter Networks, and basically we combine this framework with the first model we created. Then what we do is for the different sections we found in the first model, different levels, we compute the outlier frontier for each of the sections, and then for each week in the section we take the outliers that are above the proportion in that week. So here we have an example. Basically we can see that there are some weeks that we have a lot of outliers, and there are some weeks that we don't have any outliers. It also depends on the level of tweeting of the ego. And then when we have outliers by week, then we can perform some indicators in that. So for example, we have the Jacquard index between weeks, so how many changed from the previous week, and also how many outliers are new in each week. So the number of outliers that we have not seen before. And with that, we can see also the global analysis. This is for all users. We can see the Jacquard index, that we can see that there is a bump also in the middle of March, and also the total of outliers, probably because the level of tweeting is higher. It also increases in March. And here we can see also the same plot within each user type, and here we see the Jacquard index for different types, and we can see that it's really similar between user types. And that's it. Thank you all for tuning in, and if you have any questions, you can just ask. Thank you.